Hello, everyone, and thank you for attending today's webinar, Don't Forget the Roof. I'm Kelly Pickerel, editor with Solar Power World, and before we get started, there are a few things you should know. This webinar will be sent to all registrants, so you can view it again. Slides are available to view at any time in the resource widget at the bottom of your screen. You can submit any questions related to today's webinar in the Q&A widget. We will try to answer these during the webcast, and if we do not get to your question, our presenters may reach out to you afterwards. And finally, if you're watching this on demand, you can still use all of these features. So let's get started with today's webinar, Don't Forget the Roof. Today's speakers are Joel Stanley, he is founder and CEO of Anchor Products, and Stuart Fox, he is Director of Technical Sales at CivicSolar. Today's presentation will detail the structural and financial benefits of properly installed commercial PV systems. And now I'll turn it over to Stuart.
Hi, thanks, Kelly. My name is Stuart Fox. I'm the head of technical sales at CivicSolar. We're a nationwide solar energy equipment distributor. We're also an engineering company. We have engineering services for all of mainland U.S., and we also do a lot of work in the Caribbean and Central America. We do all grid-tied solar and all energy storage projects, and we are obviously exposed to a lot of equipment and a lot of materials, and so I'm going to be contributing some information on from the end user standpoint here, while Joel talks a lot about some of the product specific features. So the presentation, it's really going to focus on commercial roofing, of course. This is UAnchor is ideally suited for commercial projects. We're going to look at typical and the sort of the average and typical experience and conditions in commercial roofing. We're going to look at, and of course, this type of anchor product is relevant to other equipment genres outside of solar, but we're going to focus exclusively on solar here. We're going to look at designing and building, and also, of course, some key aspects of this product that link it to the financial model of the project, as well as the tax design. The objectives in this deck, in this presentation, are really, very straightforward. How a roof is assembled, identifying a roof, code requirements, how roof manufacturers, can include accessory products like their wind top roof effects. We're going to look at, how this specific product has evolved and how it's related to prior methods of attaching to the roof. We're going to look at general attachment options that are used now, a couple of case studies, and Joel's also going to talk about some interesting financial examples and, of course, ITC opportunities. CivicSolar, this is just a quick slide about CivicSolar. We've been in business for about 8 years now, where we have 3 offices across the country, really to cover the major time zones. We're about half residential and half commercial for our shipments of about 70 megawatts of equipment per year. And of course, we have a full service engineering staff as part of our team, and we have all kinds of extended engineering partners, so we can cover almost anything, anywhere in the hemisphere. I'll let Joel introduce himself and Anchor Product. This is probably a great spot to do that.
Great. Thank you, Kelly and Stuart. I'm Joel Stanley. I've been in the roofing industry for over 35 years. In 2010, I started Anchor Products from the position that I had in the roofing industry. We had a need to figure out how to attach rooftop equipment in general, as well as solar panels. In 2010, we can all remember how hot solar panels were. They were the thing. And roofing manufacturers as a whole needed a solution to how were we going to allow rooftop solar to be attached to our roofs, and how are we not going to have damage, and how are we supposed to maintain all this liability that we have? And I think when I was trying to figure this out, I figured out a method to attach rooftop solar in a safe manner, and we did rooftop solar and much, much more. So we'll go very lightly into Roofing 101. If ever anybody has any questions, my team at Anchor Products is very willing and able and capable of helping you with any of your roofing questions that you have. I get frustrated oftentimes that people don't call me enough. They get frustrated. They've been working through a roofing problem for weeks, and I can oftentimes solve that very quickly. If they'll just give us a call, we'll be glad to help in any way we can. One thing that we forgot to mention in the beginning, and maybe I just didn't hear Kelly, but this does offer you one NABCET credit for the presentation today. So I wanted to make sure everybody was aware of that. First off, let me, sorry, I got to advance through this. So first off, I want to talk about roof slope. Today we're going to primarily talk about the three primary ones here right in the beginning, with the 1 in 12, 2 in 12, and 3 in 12 slopes. Those are what you commonly find on commercial rooftops today throughout the United States. And our presentation will be focused on that. Today in the roofing industry, we have two primary different types of roofing. We have single-ply roof membranes, and we have asphaltic roof membranes. This shows what we call, or what we refer to as, a roof assembly. A roof assembly is all the components together that comprise a roof system. They typically start by outlining the deck. So you have in this case, we have a structural metal deck. We have insulation on top of that. We have a cover board above that, and then we have a waterproofing layer. Notice that the assemblies are exactly the same, whether we're having single ply or if we're having asphalt. So we commonly identify what those rooftop assemblies are, and we'll go through how each of them work later on in the presentation. Single ply membranes and asphaltic membranes can either mechanically attach them. Asphaltic membranes are commonly nailed down with a base sheet. Single ply roof membranes are commonly mechanically attached or fully adhered. So in a mechanically attached application, you have the seams of the roofing material are fastened. Nothing in between the seams is attached at all, so it allows for air movement underneath the roof membrane, which has some advantages when you're installing that product. Fully adhered applications are simply glued down to the existing insulation board or sometimes to a cover board. Trying to keep up here. Performance attributes of different roofing products. Roofing is exposed to many, many things. Oftentimes we see that roofing keeps the rain out, but roofing also is required to perform many other tasks. It has to withstand fire. It has to be, most roof systems today are non-combustible Class A roof systems. They have to withstand hail. They have to withstand extreme winds. They have to withstand extreme UV degradation. They have to withstand all the elements that Mother Nature can throw at them. They go through extreme freeze-thaw cycles. that can cause severe damage to roof systems. Many of us live in parts of the country that have experienced roof systems that, or weather days that cause the roof system to go through sometimes a 90-degree heat temperature of the ambient temperature, and that can drop all the way down to 55 degrees in the course of an hour. And that can cause a lot of expansion and contraction and movement of roof systems, which can cause degradation. We want to go through identifying different roof types. So when we look at different roof types, we want to identify what type of system this is. Here at Anchor Products, we commonly get questions, or we ask the question every day, what type of roof system do you have? And we jokingly oftentimes get the answer, I have a white roof. A white roof doesn't tell us much information. So we need to identify what kind of roofs we have, and that will tell us how we have to attach to them and what the roof systems can withstand. In the picture here, we see somebody with a core sample, and they're going to drill into that existing roof and find out what the roof assembly is made of and how it's all attached. In our picture here, we see that the roof system here is comprised, it has a metal deck, you can see that in the bottom. It has an insulation board. It has a cover board on top of that with an asphalt roof system or a single-ply roof system. I can't really see much because of the size of the picture. But so with the core sample, you drill into the existing roof, you pull out the core sampler, and you plunge out the contents. You want to make sure you keep those contents because you're going to need them later on. You evaluate the contents, you itemize them out, identify what each component is. You can measure the depth of the roof. You're going to need to know that for how long of fasteners you might need, different things like that. So there's a lot of things we can learn from doing a core sample. Doing core samples is very simple, and they're just as easy to repair. You just have to kind of know a little bit about how you're doing it and what you're doing. The roof systems that we look at, or the waterproofing layer, typically is comprised of multiple different types of roof systems. The single-ply membranes that are out there, you have PVCs, KEEs, TPOs, and EPDMs. On the asphalt side, you have APP or SBS. Those are typically the top layers. You can also have contractor supplied products or manufactured products on site for like a built-up roof system. They also have coatings that can go over the top of all of these roof systems. So the systems can vary slightly depending upon the application that you have and the environment that you're in or the climate that you're in. The roofing manufacturers have taken a lot of care in how they manufacture products for specific climate zones throughout the country. They've identified specific processes for manufacturing, different formulations. These formulations oftentimes cannot be mixed together. You'll run into chemical compatibility problems potentially, and manufacturers don't want their products mixed together. To help roofing contractors identify roof systems, Anchor Products has developed a Roof ID app. It consists of allowing you to take about 8 to 10 pictures. You submit the pictures through the app. It sends us those pictures. We evaluate them through my staff, and they identify for you and return an email back to you as far as what we believe that roof system to be, the type of roof, as well as even the brand in most cases. We're about 95% accurate, we found in that. And if we can't figure it out, we have the ability through a network of contractors that we have that we can send somebody out to look at it and identify what kind of roof system you have in all cases. When we look at code requirements for rooftop systems, basically it all starts with ASCE, the American Society of Civil Engineers. They've developed the criteria and how we calculate what's needed for roof systems. and the equipment that's installed on top of them. Over time, these codes have been in place for requirements for rooftop attachment since about 2000. In 2005, they introduced a code that we see here for ASC 7-05. You can see how things have evolved over time. So they haven't really gotten into changing the code so much as they have, as much as they've just updated or clarified things. So here we see brace all conduit greater than 2.5 in size. So in the 2010 code, they say brace all conduit equal to or greater than. So it's just providing additional clarity. But it's been in the code since 2000 to require everything to be attached. If we look at, let's see, I want to make sure I'm on the right slide. So if we look at this here in ASC 05, brace all trapeze assemblies designed to support loads greater than 10 pounds. Then they just go ahead and say greater to or equal to 10 pounds. So they're just adding some additional clarifying comments. We also see for other things, this is all about HVAC and electrical, and it also applies to all other types of rooftop equipment. So where do these things come from, or who is using the ASCE? We see the ASCE code designs being used by just about everybody. FEMA uses them, Factory Mutual uses them, otherwise known here in the slide as FM Global. We see most industries are using them. We're also seeing other groups. We see in 2006, after Hurricane Katrina, FEMA issued recommended practices for design and installation. Things have continued to evolve, and we have a 2015 code. We also have a 2016 code that's becoming accepted throughout the United States. In 2015, FM updated their standards requiring rooftop equipment to be attached. It's just that simple. Rooftop equipment, regardless of if it's an air conditioning unit, solar panels, plumbing, gas lines, whatever it is, must be attached. And we're seeing that requirement come from FM throughout the United States, not just in high wind zones. We're also seeing things from 2018 in the Uniform Building and Mechanical Code. We're also seeing it in the International Code. These things are all filtering down, and they're still using the same calculations that we've had in ASCE, Section 7. So let's see, I think I got one slide ahead of myself here. So when we look at the UMAC 3.03.8, equipment and appliances. Equipment and appliances on roofs shall be designed for enclosed or so as to withstand climatic conditions in areas in which they are installed. And we're seeing that come up over and over again, and it's being applied. I've even had contractors call me that were unaware of this code change, and they've been red tagged, and they are having to correct this problem and having to get this corrected before the building department's allowing them to move on. If we look at the IBC code, 1609.1 in applications, it says buildings, structures, and parts thereof shall be designed to withstand the minimum wind loads prescribed herein. Decreases in wind loads shall not be made for the effect of shielding by other structures. I've even seen this applied to saying that some building departments have had issues with wind deflectors that we've put on solar panels and questioning whether that will be allowed. So it's some things we need to be thinking about when we're designing roof systems when we're designing rooftop solar systems. When we look at roofing manufacturer requirements, roofing manufacturers have specific chemical formulations that they've designed into their roof systems. They do vary. Roof systems, it is not a one-size-fits-all. They do vary dramatically. If you talk about SBS is not, from one brand to another, is not exactly the same. They may not seal well to each other. They may actually degrade one another. So roofing manufacturers don't like to see their products mixed. For example, GAF does not want Johns Manville products on their building. We see this in every industry throughout the United States. You know, if you have a Toyota car, they don't really like to have Chevy parts in it. The parts may be exactly the same part. They may be made by the same third-party manufacturer, but they still don't want different brand names in their systems. We also, same as in the automotive industry and every other industry out there, we have to have authorized installers. You have to have authorized mechanics for your car. You have to have authorized repair facilities for almost everything. They want to work with people each manufacturer wants to work with people that they know, that have been trained by their staff, and that know how to work with their systems and are familiar with their installation procedures. Almost every roofing manufacturer that I've ever heard of requires roof protection sheets or slip sheets to go underneath anything that comes in contact with their roofing material. It helps with abrasion. It helps with chemical compatibility. It helps with a tremendous amount of things. I don't know of any roofing manufacturer that does not require slip sheets for every application. They also want to make sure that all their rooftop equipment is elevated to allow for drainage. You don't want to have any obstructions for drainage at all. Obstructions for drainage, inevitably in the long term, they're afraid can cause leaks, and oftentimes do. So we want to be careful with that. Moving on to rooftop wind effects. Rooftop wind effects do a lot of things. We often think of a roof system that it sits up there, because that's what it looked like when we were installing, or when we were up there looking at things. We thought that the roof looked tight, it doesn't move at all. But as we can see in this dramatization of a roof system with solar panels on it on an east-west system, what happens on a mechanically attached roof system is I mentioned before that nothing is attached between the rows of fasteners. If nothing's attached between the rows of fasteners, when you get wind movement across the roof, you create suction. You also have wind and pressure buildup inside the building. So you have air pushing up through the existing roofing and lifting the roofing system and causing it to billow. You also have air movement across the roof that causes and creating a suction effect that sucks that roof up as well, including your solar array. The effects of that create a live load on your solar system, causing your solar system to lift and come back down off many times. We don't really oftentimes understand how much force that is, but I'm a fairly large person, and it's been able to, I've been on a roof system that has actually lifted me up off the roof system itself. And it's kind of scary when that happens, but it does do that, and it will lift up a solar tray that has ballast in it without any problem at all. It seems to be able to lift me up at 270 pounds. It'll be able to pick up any solar ballast tray that's out there. We have the same effect when we look at conduit or gas lines or wire management systems that we have and the damaging effects that they have on that equipment. In this example, we're using a gas line, for example, but as the roof system billows and picks up those pipe supports, or a wire management support would be the same, it's going to lift it and make it wave and potentially damage that system. We've probably all seen conduit systems on a roof that the conduit breaks up over time. It's not so much from wind effects on the conduit, it's the wind effects on the roof structure, the roof assembly or the roof decking, causing that roof to ripple and to move, which in effect moves the conduit and moves our wire management and moves other equipment, causing that equipment to be damaged over time. I just want to show everybody an example of what that looks like on a roof system. This is the roof system in an average storm. There's people that you can see in the background on this thing. I would not envision, I got to get this to move. So I'm waiting for this video to start. Here we go. So this shows billowing of a roof system. It shows how it's not attached in the middle, and it shows how it flutters. This is probably only about, I would guess, about a 20 to 30 mile an hour wind. So it doesn't take very much to get this to move. And if you can imagine if it had solar panels on there, or if it had wire management or piping on there, how much movement you could potentially have with a system like that. And now I'm going to turn the time back over to Stuart.
Okay, thanks, Joel. Yeah, so what I was going to talk about next is really, what how have roof attachments for solar evolved over time, and where has it been in the beginning, where is it now, and kind of where is it going? So we'll look at kind of the key factors of what goes into the design of the attachment, as well as what's being used now. And so basically we've got the key factors we look at are obviously the fewer parts we can have in inventory, we can have on our trucks, we can train with, the better off we're going to be, because if we have something that's suitable for most types of roofs, then it just makes there's enough variables in construction already. It's great to have a product that is applicable to lots of different kinds of roofs. I mean, that's, for instance, look at the Unirac standard rail and L-foot that's been around for almost 30 years. It's just become it's sort of the Swiss Army knife of residential products. You could use it on almost any type of roof if you could figure out how to waterproof it. So that's an early example of residential products. And then, of course, what's the ideal envelope of your attachments? For instance, we can put solar on vertical walls. We can put it on flat roofs. Is there, how can we use products to cover as many of those instances as possible? Especially in the commercial sphere of construction. Then, of course, the speed is very important. It's directly equivalent to the labor costs on the roof. Versatility, again, of course, connects us back to install angle and roof type. We want to have something that, again, is kind of here's a pocket knife, right? But yeah, it's a Swiss Army knife of products, as far as application. Watertight, of course, that goes without speaking, doesn't make any sense to have a roof if it's not watertight. And then, of course, something very important, that Joel touched on quite a bit in the previous slides. All of these solar jobs are essentially partnerships. You want to be accepted by your structural designer. You want to be accepted by your building operations people when the project is done. And of course, if you're attaching to a roofing product, you want to be accepted by the roofers and the roofing product manufacturer, so that everybody is, happy with the installed conditions and the warranty. And finally, consistency. Again, we're just going through the ideal, components of, the ideal qualities of a roof attachment, whether it's a UAnchor or any other product. So let's just look at current attachment methods right now. This is just a sample of what we're seeing in the market, what we've seen in the market for the past 20 years. Of course, this is a lot less common than this not attaching is an option. I mean, we've certainly seen it, and in fact, I have a great example. It's very rare that you would not attach solar panels. If solar panels aren't attached, then it's usually an oversight. It's usually somebody who's extremely inexperienced. But what we do see, for instance, is we've attached solar panels very well in high wind areas. We've gotten hit by hurricanes in those exact areas, only to find out that the roofing equipment, other than the solar panels, was not attached. So essentially, the HVAC units were turned into giant wrecking balls attached by their plumbing and electrical conduit, and swung around, demolishing everything on the roof before they flew off. So fairly rare, thankfully, in well done commercial building, but it does occur. Ballast, everybody knows how ballast works. Basically, you're using enough weight to keep the equipment on the roof. So the weight of the equipment on the roof, the weight of the ballast in aggregate has to exceed the potential uplift of the wind. And ballast, of course, it's cheap, it's low tech. In theory, it doesn't penetrate the roof. But it is, if you think about how ballast works, it's very inconsistent, in my experience, from the types of ballast that are available. I mean, people just call them pavers, but they're made all over the place, and they are a chemical, essentially a concrete or cementitious chemical composition that is very susceptible to acids, especially on the roof. And we know that rainwater carries acid in it. Sometimes rainwater is fairly acidic, so it can deteriorate. But in my opinion, and this is really my opinion, but it just seems wrong to carry thousands of pounds of ballast up onto a roof to hold your solar system down. I know the roof can be engineered for that. The building can carry the load, but I think I just still have shell shock from some of the ballast pavers that I've had to carry up on the roof. There's got to be something more high-tech than this and cost-effective. However, it does work very well in some situations. So then, of course, there's the deck-mounted. This is one of the higher quality alternatives to ballast right now, and it's been around for a long time. It's the installation of it is highly technical. There's a lot of risks in the actual design and attachment of this post. Basically, it's a riser. It has to be tall enough to accommodate flashing that's weatherproofing it, but it has to be short enough to not create a high center of gravity and a lever load on the deck beneath it. So you attach something to the very top, and you're creating pressures, tension, and compression at the same time on the roofing deck below, which could be, depending on the roof gauge, might not be adequate for that tension and compression. This is a very expensive method for attaching. But again, this can work out very well, but the design and installation process is quite labor and cost intensive. So just to go back to this deck mounted option, this is very popular, especially on residential flat roofs, and can work great on residential flat roofs, but introduces a lot of risks and liabilities into larger commercial installations. Then, of course, we have just adhered or a membrane type stick-on attachment. This, again, can have a lot of risks. If you're not putting this on a fully adhered roof, all those roof movements we saw, membrane movements we saw in Joel's video, can have a disastrous effect as everything starts to undulate around on the roof because the membrane itself is moving. I think someone asked a question about another product, OMG, which I think they make. It's very similar to UAnchor, but they make a stick-on version, which can be used, I think, on a fully adhered roof. But again, the uplift strength is lower, so you would have to use obviously many more of them. Then this brings us around to UAnchor and the mechanical and weatherproofed connection. So let's look at a couple of examples here with UAnchor. Sorry, my screen just froze here for 1 second, it looks like. Yeah, I think, okay, yeah, okay, my screen's back. So we're going to go into a couple of UAnchor specific examples. So that was a little bit of the background on the genetics that have led up to this product. And Joel's going to take over now just to talk about specific uses of UAnchor for solar equipment.
Okay, thanks, Stuart. If we look at this example here, this is an aero compact. One of the several ways that they have to do this. They have a bracket that attaches. We're seeing a lot of other things be attached as well with different conduit systems and other wire management, inverters. You have controls boxes and all kinds of things that are being attached to make sure that these systems do not move in even the most severe wind application. If we look at product overview, how we develop a product. First, we have an idea. That idea can come from you, the contractor that's out in the middle of these applications all the time. That idea can come through special needs that are brought to us, special needs that we see on our own. But either way, we work through designs, and I try and involve everybody I possibly can in those designs. I want as much involvement and opinions from contractors as we possibly can. And we go through the design of those systems, and then we test it. We test it in our labs. We test it the installation process. We test with getting opinions from contractors like yourselves. What do they think of it? Does it install fast enough? Is it too expensive? There's many things that go into the testing process. And then we get into manufacturing. How are we going to be able to make this product in an effective manner that we can make it fast enough to meet the customer demand. And are those materials readily and consistently available? We also want to look at what the roofing manufacturers have to say. Anchor Products works heavily with every roofing manufacturer throughout the U.S. My family owns one of the companies listed on the board, but that's given us a lot of insight. We've been involved in the roofing industry for a very long time. And just yesterday, I left a technical meeting for the roofing industry where we were able to meet and talk about the problems throughout the industry, for codes, for product development, for installation, for many different things. And in that industry, we meet together quite frequently throughout the year to discuss the problems that they're running into with all kinds of different things. So I enjoy being a part of that team. Anchor Products, this was the very first product that we developed, a UAnchor 2000. The UAnchor 2000 is a product that just hot air welds down to the existing roofing. We'll get into the installation of each of these products in a minute. We also have what's called a UAnchor 2400. Both of those products are for single-ply membranes, either PVCs or TPOs or KEE. They can also be used for EPDMs, which are commonly black rubber. We also have what's called a UAnchor 2600, which is designed for asphalt roof systems. This system can either be torch applied or adhered with asphalt mastic. And then we have, for coated roof systems, we have a UAnchor 2600 coating. The coated roof systems, remember a coating roof system, as I said before, a coating can be put in over any roof system out there. So that we can see coatings over TPOs or PVCs or asphalt roofs or any kind of roof out there. We also have a UAnchor 2600 plate only. Some roofing manufacturers, there's two that I can think of, that they want to use their own liquid flashing to seal the roof over the top of this plate. And we've worked heavily with each of these roofing manufacturers to allow them the flexibility to flash this system in however they see best fit. They know their product and they know how the UAnchor will react with them. And so we work together as a team to develop how to install the UAnchor. And that's how we've gotten acceptance with all the roofing manufacturers. We don't dictate to them on how this gets done. We work together as a team with them. So the UAnchor 2000 is very simple to install. You set it down on the existing roof. It has alignment marks on all four sides. You align the system and you hot air weld it down into place. That's pretty much it. It's only held down primarily by the weld. And that, we'll get into some other benefits of that later on in the presentation. We have a UAnchor 2400 that it gets aligned in the same way with typically using chalk lines. Some people have done laser systems, but you set it down into place, you lift up the membrane flap and put your fasteners in through pre-designated holes on the UAnchor plate. The system can be fastened with either 4 or 8 fasteners depending upon the need. After you're done fastening, the membrane flap falls back down and you hot air weld it down around the perimeter, creating your watertight seal. And you can see in the last picture on the bottom right, you can see what a system looks like with an application of multiple UAnchors. The system for a 2600 asphalt, the plate is shipped separately. You install the plate with the same fasteners. The fasteners, by the way, I want to explain, are the same fasteners that the roofing manufacturers use every day to attach all the other roofing assembly components. So the fasteners are typically available through every roofing contractor and every roofing supply store throughout the United States. We also have them available as well. But you fasten the plate down, and then you prime the top surface of the plate with an asphalt primer that's approved by the roofing manufacturer. And then you can either torch that flashing cover over the top of the plate and onto the existing roofing, or you can adhere that with asphaltic mastic. We also have a UAnchor 2600. This application is shown over an asphalt roof. It has a coating over the top of an asphalt roof. The plate is fastened down the same way as it was in the asphalt roof. Then a peel and stick cover is placed over the top of the plate and onto the existing roofing. And then a coating is applied over the top of that peel and stick fabric product and allowed to dry. There's a separation sheet that goes on the top to allow for rubbing and different things like that for where your L foot would sit and things like that. When we look at case studies, we have case studies in some of the harshest climates throughout the world. We all know about the issues that have happened in San Juan with the massive hurricanes that have destroyed the power infrastructure for Puerto Rico. This is the project for the San Juan, Puerto Rico VA hospital. This system was a mechanically attached system that withstood all those winds. The system, from what was reported, has never lost power and has had power the whole time since after the storm without any difficulties. Another project that's well known throughout the United States is one of the largest in the United States, and that's on the Mandalay Bay project. That was 10.5 acres of roofing and about 22,000 solar panels. Another project this was, if not still, one of the largest projects in the Caribbean. It's around 1 megawatt. It's on the Westin Don Beachfront Hotel. This project is kind of unique. It's been hit by a hurricane 3 separate times without really any movement of the solar panels at all. It was hit by a Category 4 hurricane, followed about a week later with a Category 5, and the panels are still producing power today. Stuart? Or did you want me? I'm not sure if Stuart wanted me to go over these or if he was going to go over them.
Oh, yeah, sorry. Thanks, Joel. Yeah, these are your slides, I think.
Okay.
These are some financial examples. These are your slides. Thanks.
Okay. I'll keep going. Thank you. When we look at financial examples of a UAnchor, racking systems have evolved. They've evolved a lot. The racking manufacturers have come out with new designs frequently that have, in some cases, worked for us, for an attached system, and in other cases, worked against it. So let me bring up that slide again here. So just taking this example here, we're looking at a system. It's quite a large system, I'll admit. It's a 1.7 megawatt project. You're looking at, when you compare a fully attached system versus, in this application, versus a ballasted system, we have seen, including installation of the UAnchor, when we look at weight differences, you're looking at an average load of 1.77 pounds per square foot. We're able to do systems that are extremely light, and we'll get into this next slide here that we'll talk about how they're extremely cost effective. When we look at a system, a UAnchor cost for this application, this is a real life example. The UAnchor cost was $45,730. The labor to install each of those UAnchors was $32,280. We have a total cost there of $78,010. When we look at that compared to a ballast, using a cost of 3.5 cents a watt for ballast, that's the blocks and the labor to install those blocks. The ballast cost is $60,000. As we talked about before, every roofing manufacturer is going to require a slip sheet to maintain a roof warranty. That's an additional $19,190.68. To install those slip sheets, $9,500. You're going to have additional walk pads and different things like that as well that are not included. We also did not include any additional crane fees that are going to be needed for delivery of those pavers. But we're seeing a savings in this application of $11,000 over that of ballast. So there is a savings now in attached systems versus ballast. In the past, that's never been the case. People have argued that, oh, attachments are just too expensive. But with the creation of multiple types of racking systems that are on the market today, we can see that that is not the case, that we can do attached systems that are extremely light for less money. Also, is there any questions to this point? And if you do, please be sure and submit them, and we'll try and get to them at the end. If we take another financial look at the ITC opportunity with an attached system, like a UAnchor 2000, let's look at a project this is a real-life project. In 2008, a large distribution center that we'll keep unnamed, the roof they thought was in decent condition. However, it was about 10 years old, and they decided to put a very large solar system on top of the roof without addressing the roof at all. They usually look at the roof as Section 38 property, and it's treated separately. So they left it separate. Now the roof leaks. The roof leaks really bad. And with the leaks that it has on this roof system, they desperately need to repair or to replace the roof system. It's beyond repair. They've done everything that they can do. But what do now? Since they've tried to repair it and done everything that they could to repair it, they're looking to buy out their solar system or their PPA that's in place. They're looking at a $10 million buyout. They can't really afford to get out of their PPA. So what do? How do we fix the roof and keep the building occupiable so it's not leaking everywhere? Their options are to remove the roof or remove the solar, replace the roof, and then put the solar back. In this case, putting 10 or 12-year-old solar back on a roof seems a little ridiculous. The other option is to buy out the rest of their PPA, which will cost them $10 million, then replace the roof and not put solar back. They're trying to figure out what they should do for this application. If we look at what we can do with a UAnchor 2000, we have a video clip here that will show how a UAnchor 2000 works and what it does. So when a UAnchor 2000 is placed on top of the existing single-ply membrane and a force load is applied to that roof system or to the UAnchor, this is an exaggerated application of what happens, but you can see how the force load transfers down to the roofing, to the cover board, and the other roofing assembly components. What Deloitte and other tax professionals have advised us on, and we've gotten their opinions on this, is they've said that by using a UAnchor 2000, we're able to incorporate the roof system as a solar component, reclassifying the roof from Section 38 to Section 48 as energy property. So we can see how that actually transfers that load. It allows us to pay attention to the roof system as we install. It allows us to put a roof and a solar system combined on a roof that will allow the system to perform for the long term and not just worrying about how we can produce as much energy today, but how we can save the money for the roof system and create the appropriate ROI for the long run. This system can be used on thermoplastic roofs. It can used with any racking system out there. It's designed for any environment. It can be installed in high winds or your calmest wind environment throughout the United States. And it's compatible with every type of commercial rooftop out there. The system is available through a company called Subrata. Subrata offers many different services. Not only do they offer the UAnchor 2000 exclusively, they offer systems for other financial systems. They can design systems. They offer consulting services for that. They offer legal opinions. They offer cost segregation and third-party tax insurance to ensure these systems are needed. They can be involved in project financing opportunities starting at about $2 million for-profit segment, for-profit buildings only, or companies only. Thank you very much for participating today, and I'll turn the time back to Kelly.
Yeah, thank you guys. We are going to open up the floor for some questions now, and remember you can continue to submit questions in the Q&A widget at the bottom of your screen. So our first question is, what is the process of re-roofing over a UAnchor?
I can handle that. Re-roofing over the top of a UAnchor. The UAnchor is one, fairly inexpensive to purchase as well as to install. When you're re-roofing an application, the re-roofing process doesn't really allow for you to work around penetrations very well at all, regardless of what type of penetration that is. We see this question come up with life safety and many other penetrations that are on a roof. It's not cost effective to try and work around almost any penetration. You'll be much better off just replacing the UAnchor on a financial aspect when you look at the cost of trying to work around it. So that's our recommendation typically. Just take it off, put a new one down. Your roofing systems are going to be different in most cases, and it's not worth trying to work around. I hope that answers that question.
Okay. Does the UAnchor attach only to the membrane? And if so, doesn't that create risks of tearing the membrane?
The UAnchor 2000 only attaches to the roof membrane. The UAnchor 2400 and 2600 are attached to the structural decking. The testing has been done with all the different roof membrane types, and the structural engineering testing that we provide is specific to the roof type. So we have all that data on aged product, so it does not pose a risk of tearing the roof membrane. That will not happen. There is safety mechanisms built in to where the bolt that's on the UAnchor will disengage from the plate long before that would happen. There's also safety factors in an engineering design to prevent that from ever getting to that point.
Okay, perfect. What type of structural engineering information related to roof screws do you provide? And do you help define how many roof screws are needed for a specific project?
We provide the average pullout value of an individual fastener into a specific type of deck. So for example, you can say I have a 3/4 inch plywood deck, and we would in turn recommend a number 14 roofing screw. A number 14 roofing screw has a estimated or an average pullout value of, it's about 400 pounds, but I'd have to look it up to be exact. But so then you know that a single screw into a 3/4 inch plywood deck is going to have, we'll say 400 pounds. I'm going to use 4 of them. Therefore, I have 1,200 pounds for a pullout strength. If I was to use 8 of them, I would have as much as 2,400 pounds. It doesn't exactly, the math doesn't exactly work like that, but it does allow you to calculate the additional load as you add additional fasteners. So we provide the pull-out value of the fastener. We can also do on-site pull tests if required by your local jurisdiction to verify that that deck has a given pull-out value and you can adjust the engineering as needed to meet the load requirements for your specific application.
Okay, thank you. When you say you can reclassify the roof system to Section 48, are you referring only to the UAnchor product or to the entire roof system?
I'm referring to the entire roof system, parapet walls, curbs, the entire roof system, not just the roof membrane underneath the solar panels, but we're referring to a vast majority of the roof system itself.
Okay, what is the benefit of Section 38 versus 48 from a tax perspective?
There's no benefit to Section 30, to the typical roofing classification. There's only a benefit when you can reclassify it as energy property. When you classify it as energy property, now that roof system qualifies for the ITC tax incentive. The roof system qualifies for accelerated depreciation. The roof system qualifies for all the incentives that the solar qualified for because it just became solar property, not roofing. So if you want to have 30% of your roofing cost covered by the federal government in the ITC, you have to use a UAnchor 2000 and hold your system down with that, and we can reclassify that. Those systems are all designed and verified through the company I mentioned before called Subrata.
Okay, we are going to take just a few more questions. Someone wants to know, what is the diameter of the anchor post? Could a standoff clamp be used instead of screwing an L-foot onto the top?
I would have to check. We have multiple sizes of posts that could be used. Our standard post is 2 1/4 in diameter. We wanted it to be as wide as we could, but other posts could be used that would allow for additional applications. So we'd be welcome to look at those.
Okay, this will be our last question. Can you guys provide more information on the fasteners in case a roof manufacturer or contractor is not responsive?
I can provide all the information you need on the roofing fasteners from a PE report on the screw itself to whether it's ICC or LARR or whatever other information you need for the fasteners. Just give us a call at any time.
Okay, thank you. That is all the time we have for questions today. I know there were a lot of questions that came through, so if you do have additional unanswered questions, please feel free to contact our presenters on your own. This webinar will be shared again with all registrants. You can view it whenever you'd like. I'd like to thank Joel and Stuart for being here, and Anchor Products and CivicSolar for sponsoring today's webinar. And as a reminder, you will get 1 NABCEP credit for attending this webinar. So thank you to everyone for participating today, and I hope you enjoyed our presentation, and we invite you to join us for more Solar Power World webinars in the future. Thank you.
Thank you, Kelly. Thank you, Joel.
Thank you, everyone.